Today, for our real-life Orgo project, we will be teaching you about the chemistry associated with mothballs. Mothballs have been historically made from naphthalene, which look like small white balls that have a crystalline structure. It is a bicyclic aromatic hydrocarbon whose structure looks like two benzene rings put together. Mothballs have been historically made from this, but more recently have been made out of 1,4-dichlorobenzene. Both are heavily regulated due to issues we will discuss later. One key feature of naphthalene is that it can undergo electrophilic aromatic substitution. One such reaction is happening now on screen. The first step of the reaction is to generate an electrophile using a catalyst, in this case iron bromide, which will generate the Br+ electrophile that can add to the aromatic ring. Then after the electrophile has been created, the electrons from the double bond in the ring will attack the electrophile. In doing this, the ring loses aromaticity, and to regenerate this, the brominated iron bromide will deprotonate the ring, and the electrons from the hydrogen will reform the double bond and regenerate aromaticity. This leaves us with the brominated naphthalene, HBr, and regenerates the catalyst iron bromide.
Naphthalene is normally extracted from coal tar. Coal tar is approximately 10% naphthalene by weight, and it's fairly easy to extract the naphthalene. The first step is to isolate naphthalene using distillation. After distillation, naphthalene is still mixed in with some acidic and basic components of coal tar. The next step is to wash the distillate with sodium hydroxide to remove the acidic components. Those acidic components are mostly phenols. The last step is to wash the distillate with sulfuric acid to remove the basic components. The crude naphthalene is about 95% naphthalene by weight. It is possible to extract naphthalene from petroleum. In fact, extracting from petroleum leads to pure naphthalene. The crude product is about 99% naphthalene by weight. Naphthalene can also be produced when something is burned, and has been found in cigarette smoke, car exhaust fumes, and smoke from forest fires. So how do mothballs work? Mothballs have a very low vapor pressure, and that causes it to sublime. The gas can enter organisms and react with biological chemicals. The reactions with biological chemicals of the naphthalene can lead to cell damage, the effects of which are discussed later. So we use mothballs in sealed containers or storage so that the mothballs can sublime into gas, which the gas then poisons and kills bugs. It is also thought that the unpleasant odor of naphthalene can drive rodents away.
So most of the common issues that surround mothballs occur when somebody comes in contact with the solid mothballs or the gas that they sublime into. Now both the solid and the gaseous naphthalene will cause irritation to the eyes and lungs and can also cause headaches and dizziness. In the case of someone who has the inherited trait glucose 6-phosphate dehydrogenase disorder, or G6PD, coming in contact with the mothballs can actually be life-threatening. In that case, the naphthalene attacks the red blood cells of those with the disorder and it destroys them. The destruction of red blood cells is called a hemolytic anemia. And G6PD is more common in males than females, and approximately 10% of the African American population has that inherited trait. It's also estimated that around 4,000 children ingest mothballs every year. Often medical attention is required, and the results can actually be lethal if the child has G6PD. Both naphthalene and 1,4-dichlorobenzene are recognized by the international community as possible carcinogens, and because of that is very highly regulated in the United States, and the use of naphthalene has actually been banned in all consumer goods in the EU since 2008. So, as well as its use in keeping moths from eating your clothes, naphthalene has a strong connection to gasoline and race cars. There is a rumor among drag racers that adding naphthalene to your gasoline will help increase the octane of your fuel, and therefore your vehicle will run better. If you remember the octane real-life Orgo from Orgo 1, your gasoline is made up of many different compounds, and some of those compounds are arenes, and one of the arenes is naphthalene, and the octane rating of pure naphthalene is actually 90, so that's pretty high. Now, the rumor that naphthalene fuel additives is actually so popular that the Mythbusters once tested it on one of their episodes.
What's next?
Well, there's a myth going around that putting mothballs in your gasoline will be like putting high-octane fuel in your engine.
Really?
It does say, warning, flammable.
Adam pours his gas and mothball highball into the tank.
Seems steady to me.
Gradually, the Mythbusters notice a change in the engine note.
It's starting to sputter.
Yeah, it doesn't seem like it likes it.
Just to be certain, Adam revs the engine. The transformation is amazing. The engine sounds great.
Actually, that does sound kind of good, doesn't it?
Sounds much better than before. You know, barring like a bunch of instrumentation, I'd say on the face of it that we might have very well put a more high-octane fuel in this engine.
So the Mythbusters have shown that a few mothballs in the tank seems to increase the octane of your gas. We're not recommending it because the mothballs may have some negative effect on your engine too. But one thing's for certain, you won't have any moths in your motor.
So, the basis of this rumor was most likely from the early 20th century when it was more difficult to purify gasoline. At that time, naphthalene was a major component of the fuel, but the amount has been lowered over time. So, one issue with using mothballs of today's world would be accidentally using 1,4-dichlorobenzene instead of naphthalene. While it would still burn, it would likely produce HCl in the engine, which could have destructive effects. And while it is true adding naphthalene mothballs to regular unleaded gasoline would improve your octane, it likely would not do that in a race car since their octane rating is often 110. Also, since naphthalene, like benzene, has a high carbon to hydrogen ratio, it burns with a smoky flame. That would likely add carbon deposits to your vehicle. So while you may have some short-term benefits from the higher octane, the long-term problems would much likely be more expensive.
Most naphthalene in the environment will exist as a gas. Some of it may be bound to soil or taken in by plants or be deposited on plant leaves from the air. Naphthalene mostly enters the environment by the burning of wood and fossil fuels. Approximately 10% comes from coal production, less than 1% from losses during naphthalene production, and small amounts come from cigarette smoke. Naphthalene can be broken down by bacteria, fungi, air, and sunlight. In the air, moisture and sunlight can make it break down in a day. Naphthalene in water is either destroyed by bacteria or evaporates into the air. Most of it disappears from water in about 2 weeks. If naphthalene is in the soil, it will evaporate if it is near the surface. Otherwise, it can take the microorganism in the soil somewhere between 1 to 3 months to break down the naphthalene. Naphthalene does not accumulate in the flesh of animals, but if exposed to it, cow's milk and eggs will have some naphthalene. Small amounts have been found in fish taken from polluted waters. Naphthalene is considered toxic to aquatic life.
There are more uses for naphthalene and places to find it rather than just killing moths and improving octane rating. Naphthalene has also been detected in interstellar medium in the form of the protonated version in the direction of the star Cernus 52. This research has been publicized as mothballs in space. Some other places where you can find naphthalene include the magnolia plant, some species of deer, and a type of termite. This is believed to be a source of repellent to protect these plants and animals from potential predators. Hydroxy-substituted naphthalene is used in the production of precursors for dyestuff, pigments, and rubber processing chemicals, and other pharmaceuticals. Naphthalene sulfuric acids are used in the production of polymer plasticizers, which are used to produce concrete and plasterboard or drywall. This is also used as a dispersant in synthetic and natural rubbers, and as a tanning agent in the leather industry. Amino-substituted naphthalene can be found in the production of many dyes in industry, and the single largest use of naphthalene is in the production of phthalic anhydride, which is a precursor to plastics.